Hello, Mr. Woman. This is Jonas, and I'm just going to do a quick video and a quick rundown of my quiz 1. Alright. So at first here I've noted the density of ice and the density of water, and I've also have a schematic here. I also have a free body diagram to kind of help me a little bit. So there's the buoyant force and the mass of the ice, which both of these vectors are equal. And then from the hint you gave us, you said when the ice is floating in the water, base times the height of the water minus the volume of the displaced water equals the volume of water. So from that I have this equation here. So the initial volume is equal to the final volume minus the volume displaced. So since we have this equation, we're able to get an equation for the final volume, which is set up like this, and this is just pretty much algebra. Yeah, so once I had this set up, I'll be using this later on, but in the meantime, I have this set up as well, which is the density of water times the volume displaced equals density of ice times the volume of ice. And this will give us the volume of ice. So no, the volume displaced, sorry. So what I have set up is volume displaced equals density of ice times volume of ice, and we're going to divide that by density of water. And we have all these numbers, and all we're going to do is just plug it in, like so here, and we get 4.5006 E minus 6 cubic meter for the volume displaced. I've also calculated the volume of the ice. Actually, I calculated the volume of ice before finding the volume displaced. So the volume of ice would be pi r squared times h. So pi times 1.25 e minus 2 meters squared, because this is the radius in meters, and it was given to us in centimeters, so I just converted it to meters, times 1 e minus 2 meters. And that gave us 4.908 e minus 6 cubic meter, and I was able to plug that into here. And so the volume displaced would be 4.5006 e minus 6 cubic meter. Now we can find the height of the water in the glass in millimeter once we add the ice cube to the water in the glass, which is here. So H2 equals 1E2 times pi times 1.5 e minus 2 meters squared plus the volume displaced, which is 4.5006 e minus 6, which I got from solving up here. When we calculate this out, I get 0.0163670 meters, but you wanted that in millimeters, so you just convert it to millimeters, and I get 16.4 millimeters as my answer. And yeah, that's it.